Good morning, guys. Welcome back. Today is our second session related to Kubernetes workshop. In the yesterday session, we discussed what is Kubernetes and why we need to go for Kubernetes. What are the advantages with the Kubernetes and Kubernetes architecture and how to set up Kubernetes cluster by using AWS EKS service. So these topics we discussed. Kubernetes is one of the most famous open source orchestration platform that is used to manage our containers. When we are running our application, right, multiple containers we are going to create. So creating those containers, managing those containers manually is a difficult process. That is the reason we are going to use orchestration platform in order to manage our containers. Kubernetes is providing a framework in order to manage our application deployment, application scaling, application load balancing. Now, what are the main advantages with the Kubernetes? Container orchestration is one advantage, auto scaling is one advantage, self-healing is one advantage, and load balancing is another advantage. Here, container orchestration means, as we discussed, managing the containers, creating the containers, scale up the containers, scale down the containers will be taken care by Kubernetes. Auto scaling means based on the demand, the containers count can be increased, containers count can be decreased. So in the Docker, we call it as a container, but in the Kubernetes, we are calling it as a pod. So number of pods creation, pods deletion, pods increasing, pods decreasing will be taken care by Kubernetes. That's why it is called as auto. Next one, self-healing. If any one pod is deleted, then Kubernetes will replace that with another new pod. So always our application will have high availability. Then load balancing. When our application is running in multiple pods, then load will be distributed to all the pods in the round robin fashion. Next, architecture of the Kubernetes. Kubernetes will follow cluster architecture, guys. Nothing but group of servers will be available. One is called as master node and the remaining things are called as worker nodes. Master node is also called as control plane. And we will communicate with the control plane by using kubectl concept. Kubectl is a command line utility to communicate with the cluster. In the control plane, we have these components. In the worker nodes, we have these components. In the last session, we already discussed what are these concepts and what is the purpose of each component in the cluster. Then API server will receive the request and will store in the etcd. Then etcd is a cluster database. Scheduler will schedule the pending tasks and will assign the task to the worker node. Scheduler will get the worker node information by using node agent, which is a kubelet. Then kube proxy will provide the network for the cluster communication. And pod is the actual thing where our application is going to run. Pod is the smallest building block that we run in the Kubernetes cluster. Pod represents runtime instance of our application. In Kubernetes, our project will be executed as a pod. Inside pod, containers will be created. And the controller manager is going to manage all the resources that are working as expected or not. Then we discussed about cluster setup, guys. The setup document I have already shared. Okay, by using this document, by following the steps which are available in the document, we can do the Kubernetes cluster setup. So by using this document, we can set up Kubernetes cluster. Is my voice clear for all of you now? Is my voice clear for you? Right? Perfect. So with this, we are able to done Kubernetes cluster setup. Now, if you see, so I have connected with my machine. By using this machine, I have done the Kubernetes cluster setup. So kubectl get nodes. If you use the kubectl get nodes command, then it is going to display the cluster resources. So if you see here, my cluster is ready. There are 2 worker nodes available in the cluster. 15 minutes back only, I have created the cluster. In the yesterday session, we created the cluster and immediately I have deleted the cluster also to avoid the billing. And remember, EKS is not free, guys. EKS is a paid service in the AWS, right? So that's why yesterday cluster I have deleted and today before coming to the class, I have configured the cluster again. My cluster is up and running, which is in the state ready. There are 2 worker nodes available in the cluster. Now, so once the cluster is ready, I want to deploy my application in the cluster. So let me go to Kubernetes architecture diagram so that it will be clear for us. Let me open the Kubernetes architecture diagram. Now, if you see in the Kubernetes architecture, we have control plane and we have worker nodes. Now I want to deploy my application by using this Kubernetes cluster. So to communicate with the Kubernetes cluster, we have installed kubectl. By using kubectl command, we can connect with the control plane and we can give the task to the control plane. Then control plane will assign the task to the worker node. Okay, so here already kubectl is available in the EC2 machine. I created one EC2 machine. By using this machine, we created the cluster. So when I execute kubectl get nodes command, it is displaying how many worker nodes available in the cluster. So currently here, there are 2 worker nodes available in the cluster. And let me check kubectl get to pods. How many pods are running in the cluster? Currently, there are no pods in the default namespace. So no application we have deployed. Currently, pods are not running in the cluster. Now, in order to deploy the application, we need to create the pod. Okay. Before going to understand the deployment part of the application, we need to know 2 concepts in the Kubernetes. Then only we can do the application deployment. First one, what is pod? The first concept that we need to learn in the Kubernetes, what is pod and how to create the pod. In the Kubernetes, guys, pod is a smallest building block that we can run in the Kubernetes cluster. If you want to deploy any application in the Kubernetes, for that application, you need to create a pod. There is no full form for the pod, guys. This is the name pod. Pod is a smallest building block that we can deploy in the Kubernetes cluster. So any application that you want to deploy in the Kubernetes cluster, for that you need to create the pod. Our application will be deployed in the Kubernetes cluster as a pod. Suppose if you want to deploy your application with multiple instances, then you need to create multiple pods for your application. For one application, we can create multiple pods also. Why we need to create multiple pods for one application? If you create multiple pods for one application, high availability will be there. If one pod is deleted also, if one pod crash, if one pod is damaged, then no problem. Other pod will be available to execute our application. That is the reason in the real time, for every application, multiple pods will be created. Pod is a smallest building block that we can deploy in the Kubernetes cluster. Our application will be deployed in the Kubernetes cluster as a pod only. For one application, we can create multiple pod replicas for the high availability. And whenever you create a pod, for every pod, one IP address will be generated. For every pod, one IP address will be generated in order to access. And here, if any pod is damaged or if any pod is crashed, then Kubernetes will replace that pod. That concept is called self-healing. That concept is called self-healing. Okay, guys. If Kubernetes pod is damaged, then it is going to replace the pod. Guys, are you clear with my point? What is the pod and why we need to go for the pod? Pod is the smallest building block that we can deploy in the Kubernetes cluster. Our application deployment will happen by using pod only. For one application, we can create multiple pod replicas for the high availability. For every pod, one IP address will be generated. If a pod is damaged or if a pod is crashed, if pod is damaged or if a pod is crashed, then Kubernetes will replace that pod for the self-healing process. Okay, next one. Here, to create the pods, we are going to write manifest YAML. I want to create the pod. To create the pod, we are going to use a YAML file. That YAML file are called as manifest YAML file. Okay, within the YAML, we will specify what pod we need to create, by using which Docker image you want to create the pod, how many containers you want to create in the pod, what is the pod label, all that information we are going to specify in the manifest YML. And another thing is, whenever you send a request to the control plane to create the pod, by using, I will write one YML file. In that YML file, I will declare my pod manifest and I will execute that YML by using kubectl. Then control plane will take my request. Control plane will assign the task to the worker node. Inside the worker node, my pod will be created. When the pod is created in the worker node, we cannot access the pod directly, guys. Okay, so I will write one manifest YML. That manifest YML, I will execute by using kubectl. Then the pod will be created inside the worker node. So kubectl is used to communicate with the control plane. I will assign the task to control plane. Control plane will assign the task to worker node. Inside the worker node, our pod will be created. By default, pods are accessible only within the cluster. You can't access the pod outside. That means you can't access your application directly if you create only pod for that. Then what we need to do to expose the pod outside the cluster, we need to implement a concept called service concept. First, we need to create the pod. Once the pods are created, those pods we need to expose. Those pods we need to expose by using services concept. Are you guys able to follow me? First, we need to create the pod. By default, pods are accessible only within the cluster. If you want to access the pods outside the cluster, then we need to use service concept in the Kubernetes. Okay. Are you guys clear with what is pod in the Kubernetes? Pod is a smallest building block that we can deploy in the Kubernetes cluster. So if you see in our application, we need to create the pods. So using kubectl, I will connect with the control plane. By using the kubectl, I will execute my YML. In that YML, I will specify the configuration to create the pod, which Docker image it has to use to create the pod, what is the name of the pod, what is the label of the pod, everything we are going to specify in the YML. That YML I will execute by using control plane. Then what that control plane will assign the task to the worker node. There are two worker nodes available. So in any worker node, it can create the pod. So pod is the smallest building block that we can deploy in the cluster. So if you want to deploy your application deployment in the Kubernetes means creating the pod only. For one application, you can create multiple pods. What is the benefit of creating multiple pods? High availability will be available. Suppose I created 3 pods. One pod got deleted. No problem. Kubernetes will replace that pod with the another pod. Self-healing will be available for the pods. Okay. Then here for every application, multiple pods will be available. So whenever you create the pod, outside you cannot access the pod. So pods we can access only within the cluster. Sir, how can we access the application running in the pod in our system? Then whatever the pods are created, those pods we need to expose by using a service concept in the Kubernetes. So are you guys clear with what is pod? Are you guys clear with the concept of what is pod in the Kubernetes? Pod represents runtime instance of our application. Pod represents runtime instance of our application. If you want to deploy any application, then that will be deployed by using pods only. If you want to deploy any application, the application will be deployed by using pods only. Pod is a smallest building block that we can deploy in the Kubernetes cluster. How to expose the pods? In order to expose the pods, we are going to use a concept called service concept. Okay, what is a service in the Kubernetes? Kubernetes service is used to expose the pods. Whatever the pods we have, in order to expose the pods, we are using service concept. Okay, in the Kubernetes, there are 3 types of services available. In the Kubernetes, there are 3 types of services available. What are those 3 types of services? First one is called cluster IP. Okay, whatever the pods we have created in the worker node, all the pods we can expose by using one IP address. For every pod, a separate IP will be available. But for all the pods, I want to give one single IP for the load balancing. So if you want to expose all the pods by using single IP, then you can use cluster IP. But cluster IP is used to map. Every pod will have its own IP. Every pod will have its own IP. But all the pods I want to access by using single IP address for the load balancing purpose. Then you can go for a cluster IP. If you use the cluster IP, the pods will be exposed only within the cluster, but not outside. Okay. Suppose, for example, when we are going to deploy the database in the Kubernetes cluster, then database, I don't want outside people to access my database. Then the database I will expose by using cluster IP. For database, I will create 3 pods. For 3 pods, I want to give the single IP address. But those database pods should be accessed only within the cluster, not outside the cluster. Then we can give cluster IP service. We can use cluster IP service to expose the database pods. For example, I'm deploying my application. I want to access my application outside of the cluster. Then there is a service type called NodePort. So NodePort is a service which is used to expose the pods which are running in the particular worker node. Now there are 2 worker nodes available. My pods are created in the both worker nodes. I want to create 4 pods for my application. 2 pods created in the first worker node, 2 pods created in the second worker node. So which worker node pods you want to access outside, that you can expose by using NodePort. Okay. So if you want to expose your pods for access, we need to use a service concept in the Kubernetes. So in the Kubernetes, there are 3 types of services available. One is called cluster IP, which is used to access the pods within the cluster only, within the cluster, not for outside the cluster. If you want to access the pods outside the cluster, then there is a service type called NodePort is available. When you go for NodePort, you can access the pods which are running in the particular worker node. Okay. But if you want to access the pods running in all the worker nodes in the load balancing mechanism, then the service type is available as a load balancer. My application is having 10 pods, 5 pods running in one worker node, remaining 5 pods running in another worker node. Okay. Then if you want to access all the pods with the load balancing technique, then we need to expose those pods by using a concept called load balancer. These 3 are called as services in the Kubernetes. First, we need to create a pod, and those pods we are going to expose by using service concept. Kubernetes service is used to expose the pods. We have 3 types of services in the Kubernetes. One is the cluster IP, second one is NodePort, and the third one is load balancer. Are you guys clear? Are you guys clear with what is pod and what is the service? Are you guys clear with what is pod and what is the service? Are you guys clear with what is pod and what is the service? Can you tell me what is pod and what is the service, guys? Can you respond in the chat box? What is pod and what is the service, guys? What is the pod and what is the service? Pod is a smallest building block that is used to run our application. If you want to deploy your project in the Kubernetes, then you need to create the pod only. To create the pod, we will write the YAML file. To create the pods, we are going to write the YAML file. Okay. Once the pod is created, IP will be generated. Can we access the pods outside the cluster? We cannot access the pods outside the cluster. We cannot access the pod outside the cluster. Then how to expose the pods to access outside of the cluster? By using service. Service is used to expose the pods. How many types of services available in the Kubernetes? How many types of services available in the Kubernetes, guys? There are 3 types of services available in the Kubernetes. What are those 3 types of services in the Kubernetes? One is cluster IP, second one is NodePort, third one is load balancer. What is the meaning of a cluster IP? Cluster IP is used to access the pods within the cluster. Okay. So if you are deploying the database in the Kubernetes, database pods, we don't expose for outside people. Database pods, we will access only within the application, within the cluster. So any database, if you are deploying in the Kubernetes, database pods we will expose by using cluster IP within the cluster. Suppose if you are deploying the application pods we can expose by using NodePort and load balancer. What is the difference between NodePort and load balancer? Can you guys respond? What is the difference between NodePort and load balancer? Can you tell me the difference between NodePort and load balancer? What is the difference between NodePort and load balancer? NodePort is used to access the pods belongs to particular worker node. Okay, NodePort is used to access the pods belongs to particular worker node. If you want to access the pods belongs to all the worker nodes, then which service? Load balancer service we are going to use. Are you clear with my point? Are you guys clear with my point? Are you guys clear with my point? Now, I want to create the Kubernetes manifest YAML to create the pod and expose the pods by using service concept. So when you are going to write the Kubernetes manifest YAML, we need to follow some syntax. Okay, guys? Kubernetes manifest YAML syntax. Manifest YAML, it will start with 3 hyphens, end with 3 dots. Okay, let me save these notes for time being. All right. Now, Kubernetes manifest YAML I want to write. So what sections we need to write in the YAML file? In this YAML file, 4 sections will be available. One is called API version. Okay. Second one is kind. Third one is metadata. Fourth one is spec. These are the 4 sections we are going to keep in our manifest YAML. So API version and kind, metadata, specification. So in the Kubernetes manifest YAML, we need to write these 4 sections in order to create the pod, in order to create the service. Okay. Now, when I want to create the pod by using this manifest YAML, what is the configuration we need to write in the YAML? Observe carefully, guys. First time, it may be a little bit confusion for you, but if you practice, then you can understand how to write this manifest YAML files. Okay, when you are going to write the manifest YAML file, I'm going to write a manifest YAML file to create the pod and the service. I want to create the pod and I want to expose the pod by using service concept in the Kubernetes. Okay, so to create the pod, API version, I'm going to specify apps/v1. Sir, what API version we want to use? That we can identify in the official Kubernetes documentation. Okay, I want to deploy my application by using Kubernetes cluster. I want to create the pods and I want to expose the pods by using a service concept. API version apps/v1. Kind, what you want to do? I want to create one deployment in the Kubernetes. Kind is a deployment. API version apps/v1. Kind is a deployment. Kind deployment means I want to create one deployment in the Kubernetes. I want to deploy my application. Metadata. For this deployment, can you give some name? Yes, I'm giving some name for the deployment, which is Java Web Application Deployment. Okay. What deployment you are creating in the Kubernetes? For the deployment, you give some name by using metadata. Then coming to the spec, how many pods you want to create for this deployment? Replicas, 2. I want to create 2 replicas. That means I want to create 2 pods. If you give 5, then 5 pods will be created for your application. Why we need to create multiple pods for our application, guys? What is the reason for creating multiple pods for our application? For a high availability. If any one pod is deleted, then remaining pods are going to allow the traffic. That means the load balancing will happen, load distribution will happen when you create multiple pods. To achieve high availability, we are going to create multiple pods. And what is your deployment strategy? So there are multiple strategies available. I'm using rolling update. I'm using a strategy called rolling update strategy for that. Then deployment strategy type is a rolling update. Deployment strategy is rolling update, right? So I want to create a pod, API version apps/v1, kind is a deployment, metadata, name is Java web application deployment. Under the specification, we are giving 2 replicas, and the deployment strategy we are going to follow as rolling update strategy. Recreate, rolling update, canary. There are 3 strategies available. Currently, I'm using one strategy called rolling update. Then next one, here we are going to specify selector. That means labels we are going to give for the pod. So selector, match labels. What is your pod label? For the pod labels, I'm giving the label name as app Java web. So this selector is going to represent pod label. That means which pod you want to deploy. Which pod you want to deploy, that we are specifying by using match label. My pod label name will be Java web app. Once it is completed, then we need to create the pod template. As of now, we have taken deployment manifest. Now, pod template we need to specify. In the pod template, we are going to specify metadata. What is the metadata? The pod name. You can give any name for the pod. I'm giving the name as Java web application pod. I'm going to deploy one Java web application by using pod. So the pod name I am giving as Java web application pod, and for the pod I'm giving labels. The label name is Java web app. And remember, whatever the label name you are giving for the pod, same label name we are going to specify as a selector. Kubernetes deployment should create the pods and should follow the deployment strategy. So this is the pod template. For this pod template, I'm giving a label name. This label name we need to configure as a selector. Then once the label is configured, then specification for the pod. Okay. So what is your pod specification? That means where is your Docker image to create this pod? So the Docker image information will specify by using specification. So inside the pod, what container you want to create? Inside the specification, I'm specifying my containers information, container name. I'm giving the name as Java web application container. To create this container, I need to give the Docker image. My Docker image is available in the Docker Hub. The Docker image name is Ashok IT/Java web app. So this is my Docker image for the application. Already this Docker image is available in my Docker Hub account. So by using this Docker image, this container will be created inside the pod, and for that pod, 2 replicas will be created. And this container is going to run on the port number. Ports will be available. The ports, container port. This is a Java application which will run on the Tomcat server with the port number 8080. With the port number 8080. This is a manifest YAML which is used to create the pods for my application. Okay, so there are mainly 4 sections available. API version, kind, metadata, and spec is available. API version is apps/v1, and I want to create a deployment. For this deployment, I am giving some name as a Java web application deployment. How many pods you want to create? I want to create 2 pods. So 2 replicas I want to create. Strategy, I want to go for rolling update strategy. And which pods you want to expose by using this deployment? Here pod template is available. In the pod template, I'm giving the name for the pod template, pod name, and pod label. Labels and selectors are very important. Label is nothing but the ID for the pod. Label is used to identify the pod. This pod label is app Java web app. You can give any name for the label. Label is like an ID card. So with this label, it will identify that by using selector. And inside the pod, what container you want to create? I want to create a Java web application container inside the pod. This is the name for the container, and this is the image for the container. And ports, container port I am giving as 88. So this is called as our pod manifest YML. This is called as our pod manifest YML. By using this pod, we are deploying our application. Okay. So now, if you create this, can you access this application outside? Can we access these pods outside the cluster, guys? If you create the pod now. If you create the pod now, can we access these pods outside the cluster, or we cannot access the pods outside the cluster? Can we create these pods outside the cluster? Can we access these pods outside the cluster? We cannot access the pods outside the cluster. We cannot access the pods outside the cluster. So what I need to do to access these pods outside the cluster? What I need to do to access the pods outside the cluster? We need to expose by using service concept. So what services available in the Kubernetes? Cluster IP, NodePort, cluster IP, NodePort, and cluster IP, NodePort, and load balancer is available. Cluster IP means within the cluster only we can access. NodePort means particular worker node IP we will use to access the pods. Load balancer, which will give you the access for all the pods available in all the worker nodes by using load balancing technique. Now, so we need to expose the pods. We need to expose the pods. To expose the pods, we need to create the service. To expose the pods, we need to create the service concept. Are you getting my point? In order to expose the pods, we need to create the service concept. So for the service, again, manifest we have to write. So API version, service manifest you can write separately or you can write in the same also. Kind, metadata, and spec will be available. 4 sections will be available. So this is our deployment manifest to deploy the application by using pod. And these pods we need to expose. For that, we are going to write the service. API version, kind, metadata, and spec. API version, we are going to give this as V1 for the service. Kind. Kind represents what you want to create. What you want to create by using kind section service. What we want to create is that the service that we need to specify. And metadata. What is the name you want to give for the service? I want to give the name as Java Web App Service. I want to give the name as Java Web App Service. Okay, guys. Then next one, spec. Spec means specification of the service. What is the service type? I want to specify the service type as load balancer. I want to expose these pods by using a service called load balancer service. Okay, so when you specify type as a load balancer, then the pods will be exposed as load balancer service. Which pods you want to expose by using load balancer? Selector. Selector will represent pod label. The pod label is Java web application. This is the label. So these are the pods. This is pod template. This is used to represent our pod template. So I want to create a container inside the pod by using this Docker image. For this pod, I am giving the label as app::Java web app. Okay, so these pods I am exposing by using a service called load balancer type. So this service should identify which pods it has to expose. That's why the pod label we are configuring as a service selector. Pod label we are configuring as a service selector. Then after this one, port mapping. So our application will be running on the port number 8080. I want to map this to the port number 80. The container is running on the port number 8080 and load balancer port I want to map to 80. This is port mapping, which is used to access our pods by using load balancer service. Okay, so this is our manifest YML, guys. This is our manifest YML. This is used to create the pod. I want to create the two pods for the application, and the pods having the label. This pods should be created by using which Docker image. The Docker image name also I'm specifying here. Once these pods are created, the pod label is available. By using this pod label, we are exposing the pods by using load balancer service. Writing this manifest YML requires a lot of practice. So this is a workshop. So I'm not focusing on butifying this YML file for you now, guys. So I will show you how to create the deployment, how to expose the pods, how to access the pods. In the Kubernetes class, as I told you, Kubernetes course will take 2 weeks of time, right? In that 2 weeks of time, you are going to learn this concept only. How to write the pod manifest YMLs, how to create the services by using YML, how to create the namespaces by using YML, how to create blue-green deployment by using YML. The 2 weeks of time I told you for the Kubernetes course, right? In the 2 weeks of time, we are going to learn this YML. As it is a workshop, I can't spend that much amount of time here to deal with all these things. Okay, so I will give you this YML file in order to create the deployment. After this workshop, you need to focus on how to write these YML files. Okay, it requires some practice, guys. Within 1 hour, within 2 hours, you can't understand these YMLs. So it may take 1 week to 10 days of time to understand how to write these YMLs. So Kubernetes course means they will tell you how to write these YMLs. So we have a time constraint. It is a 2 days free workshop. So I will show you how to execute this YML and how to deploy this. Are you guys clear? So in the interview, they will ask the questions. Could you please write a YML file to create a service? Could you please write a YML to create the deployment? How do you create the pods in the Kubernetes? Could you please explain what is the deployment strategy you are following? So could you please explain what is the label and the selector in the Kubernetes YML? So there are so many interview questions will be asked from these YML files only. So if you want to work with the Kubernetes, then you need to learn how to write these YML files in the Kubernetes. This YML file writing, you can learn within 1 week of time. You need to spend minimum 1 week of time to understand how to write these YML files. Are you clear? Are you guys clear with my point? Now, once this YML file is available, then you can go and create the deployment and you can access them by using this manifest YML. Okay. So look at this YML. Just read that YML from top to bottom once. Look at the YML from top to bottom once. Just for our understanding purpose. Strategy rolling update, recreate option will be available. Rolling update means when you are redeploying the application, it will create the old pods and it will delete the old pods and it will create the new pods. That is rolling update. There are 3 strategies available in the deployment: rolling update, recreate, and canary. Rolling update is available, recreate strategy is available, and the canary strategy is available. Indentation is very important. You need to follow the indentation. This is a YML, or we can say YAML. Indentation is very, very important when you are writing these YMLs. You need to follow the indentation. Yeah. So if you are not understanding this YML file writing, no problem, because our concentration is not to write this YML today. I told you. So it will take 1 week of time to learn this YML file. It will take 1 week of time to learn this YML file. If you are listening for the Kubernetes first time, writing this YML is definitely time-taking process. Are you clear? So this first section will represent a deployment for the pod. Second section will represent the service for the pod. Now, whatever the YML file we have, that YML file we need to create in our machine. Okay, let me connect with this machine. Now, in this machine, we will create this YML. In this machine, we'll create the YML ls-l. So currently there is no YML file available. I'm going to create the YML to deploy my application. Deployment.yml. So vi Java web app deployment.yml. This is called our Kubernetes manifest YML. I'm keeping our manifest YML here. So this is deployment section and this is my service section. Both are available in this YML, and the service type I'm using as load balancer. So I'm going to specify replicas to 2. So 2 pods will be created. Those 2 pods we are going to expose by using load balancer service. All right. So with this, my YML file is ready. With this, my YML file is ready. Once the YML file is ready, then we need to create the pods. Okay. How we will create the pods now? We need to execute kubectl commands. So observe carefully. My YML file is ready. So now, before going to see this execution, can you see, is there any load balancer available in the EC2? We have used service type as a load balancer. Is there any load balancer created in my AWS account? Currently, load balancer is available. Currently, load balancer is not available. Currently, no load balancers available. When you execute this YML, we have created service type as a load balancer. So it is going to create one load balancer. It is going to create one load balancer to access our pods. Let me execute first. kubectl get pods. Any pods available? No pods available. kubectl get service. Any services available? No service is available. One service, that is the default Kubernetes service available. Our application service is available, or our application service is not available. For our application, one service is available or not available? No. Currently, no pods available. Currently, no services also available. And any deployment is available. Any deployment is created. Kubernetes get deployment. Now, before executing my YML, I'm checking what are the pods available, what are the services available, what are the deployments available. So here, currently no pods available, no services available, no deployments available. Now, I want to execute this YML file. So before executing this YML, I'm using a command called kubectl get pods command. What is the purpose of get pods? To see what all the pods available in the cluster. Now, I want to see what all the services available. kubectl get service. This is going to display what services you have created in the Kubernetes cluster. If you want to see what deployments you have created in the Kubernetes cluster, we will use kubectl get deployment. I have executed 3 commands. I'm not able to see any pod. I'm not able to see any service. I'm not able to see any deployment. Okay. Now, so what is this command purpose? kubectl get pods command. This is used to check the pods which are running. What is the purpose of get service? It is used to check services running. Check services running. And kubectl get deployment. Check deployments created. Check deployments created. Check services created. Check pods running. Okay. If you want to see what all the pods running in the Kubernetes, then you can use kubectl get pods command. What is a kubectl? kubectl is a command line utility which is used to communicate with the Kubernetes cluster and check what all the pods running. kubectl get service. It is used to check what all the services created. kubectl get deployment. what deployment is created, I want to check that. Okay, suppose if you want to see the pods running in the which worker node, okay, check pods running in which worker node. So two pods. So these are two pods created in first worker node or in the second worker node. I want to check the pods running in which worker node. For that, kubectl get pods -o wide. If you use -o wide, then that will display your pods are running in which worker node. Okay, so two pods I have given, right? Those two pods are running in the first worker node. Those two pods are running in the second worker node. We can check that by using -o wide option. Then how to create the deployment, how to execute the YML. In order to execute the YML, okay, execute Kubernetes manifest YML. Execute Kubernetes manifest YML. To do that, we will use a command called kubectl apply -f our YML file. Okay, kubectl apply command we are using to execute that YML. Kubectl apply -f YML. So with this, that YML file will be executed. So in this YML, what we have given? We have given a deployment, we have given pod template, and we have given service. So pods will be created, deployment will be created, service will be created. Service type we have given as a load balancer. So as the service type is a load balancer, in the AWS, one load balancer will be created. We are using AWS EKS cluster. So when you use service type as a load balancer, the load balancer will be created in the AWS. Using that load balancer URL, we can access our application. Okay, so look at the commands that we are going to execute. Kubectl get pods. What is the purpose of kubectl get pods command? Kubectl get pods command will show you what all the pods running in the cluster. Kubectl get pods -o wide, which is used to display the pods running in which worker node. Kubectl get service, which service you created to expose the pods, we can check it. Kubectl get deployment. So you need to deploy your application by creating the pods. What is the deployment that you can see? How to execute this Kubernetes YML? In order to execute this Kubernetes YML, kubectl apply -f YML file. Okay, so if you use kubectl apply -f YML, then the YML file will be executed. In that YML, whatever the resources you configured, those resources will be created in the Kubernetes cluster. Those resources will be created in the Kubernetes cluster. Are you guys able to follow me? Are you guys able to follow me? Are you able to understand the commands that we need to execute? Are you able to understand the commands that we need to execute? Shall we execute them and check it? Forget about YML file, guys. So I'm not here to explain the YML today, because YML you can't, this YML creation you can't learn in 1 hour, you can't learn in 2 hours. As I told you, 10 to 15 days if you spend, then only you can learn how to write those YML files. Today's agenda, not to understand the YML. Today's agenda, how to deploy the project in the Kubernetes, how to access that project by using Kubernetes service. That's it. If you join for the Kubernetes course, not only in our institute, in any institute, they will teach you how to write these YMLs. So I will take 2 weeks for only Kubernetes class. For Kubernetes syllabus, we are going to spend 2 weeks of time. In the 2 weeks, we will learn how to work with these YMLs. Daily 1.5 hours, almost 15 days plus almost 20 hours we will spend only for the Kubernetes. So in that 20 hours, you will learn this YML. This workshop is only 2 days, right? So within 2 days, you can't learn this YML. If you are not able to understand how to write the YML, leave it. So I will give you this YAML. You just look at these commands, how to execute the YAML. Once you join for the Kubernetes course, then you can learn how to write that YAML. Are you guys clear with the commands now? Can we execute this and can we see our application is deploying in the Kubernetes or not? Yeah. My YAML file is already available in this machine. Now, let me go and execute it. Okay. I got disconnected from the machine, connect back. I connected back to my machine. In this machine, I have the cluster access. By using this machine, kubectl command, I can communicate with my Kubernetes cluster, guys. Okay. So in this machine, kubectl is available. Using that kubectl, I can communicate with my Kubernetes cluster. Now, I connected to my EC2 machine. In that machine, my kubectl is available. Using the kubectl, I will communicate with the control plane. Control plane will communicate with the worker node. Control plane is going to communicate with the worker node. Inside the worker node, pods will be created. In which worker node pod will be created, that will be decided by the control plane. In which worker node pod will be created, that will be decided by the worker node. And those pods we are exposing by using service. All right. Good. Now check the pods again. kubectl get pods not available. Then check again. kubectl get service. Application service is not available. kubectl get deployment. kubectl get deployment. Deployment is also not available. Okay. No pods, no services, no deployments. Now I need to execute my YAML. So my YAML file is already available in this machine. Java web app deployment.yml. We need to apply this YAML. How to apply this YAML? kubectl apply -f file name. File name can be anything. There is no naming convention for the file. So my file name is Java web app deployment.yml. kubectl apply -f this web app deployment.yml. Now you can see the YAML file is executed successfully. My deployment is created. My service also created. The application deployment is created and application service also created. Nothing but my pods are created. My pods are exposed by using service. So when we are writing this YAML, we should be careful. The spacing, the indent spacing is also very, very important. If you do a small mistake with the space also, the deployment will not be created. So we have written the perfect YAML and we are able to execute that YAML by using kubectl apply command. My deployment is created. My service is also created. Okay. Then how to check it? Is it really created or not? Now go for kubectl get pods. Now you can see there are 2 pods created and those 2 pods are in the running status now. kubectl get pods. So 2 pods created. This is the name of the first pod and this is the name of the second pod. They are in the ready state and they are in the running. From 48 seconds, those pods are running. So with this, we are able to see the pods status. kubectl get pods, 2 pods are running. In which worker node those pods are created? -o void. Okay. Now it will display the pods are running. See, this is the pod IP and where these pods are running, you can see the node IP also. So in which worker node those pods are running, node IP is also printed. So this is running in the 192.168.21.176 and this is running in 192.168.117. So that means 2 pods are running in 2 different worker nodes. So I have given pod count as 2 pods created in 2 different worker nodes. How we are able to see the pods are running? This is pod IP. This is pod IP. This is pod IP. 2 pods are running. Node IP. This is the first pod node in which worker node it is running. This is the second pod node IP in which worker node. So this is running in 176 node IP. This is running in 117 node IP. You can go to our EC2 dashboard and you can see the instances. There are 2 worker nodes are running. Select this worker node. Node IP is available. Okay. And this is the second worker node IP is available. 176 IP is available. And 117 IP is available. One pod is running in 117 IP and the second pod is running in 176 IP. So two pods are running in two different worker nodes. Who created those pods in the worker nodes? I have created, or my control plane will decide that? I have created, or my control plane will decide that? I have given the task to control plane. Control plane has assigned the task to worker node. Those pods are created in the worker node. I have given pod count as 2. So 2 pods are created in 2 worker nodes. And check the service here, whether the Kubernetes service is created or not. kubectl get service command. kubectl get service. Yes, one service is available. That is the Java web application service is available. Service type is a load balancer. This is the load balancer URL in order to access our application. Now go to AWS load balancer section. Earlier, 0 load balancers available. Now you see one load balancer is created in the AWS. Now refresh the load balancer section. One load balancer is created. Then click on this load balancer. For the load balancer, DNS will be available. This is the DNS name of the load balancer. By using this DNS name, we can access our application. Okay, hit this URL, the application load balancer is created. Okay, now you can check the deployment also. kubectl get a deployment. What is the deployment created? How many pods created in the deployment? So deployment is created. I told to create the 2 pods in the deployment, 2 replicas created, and they are available and they are up to date, they are running. My deployment is ready. Now, if you want to undeploy the application, you need to delete the deployment. If you delete the deployment, your pods will be deleted, your services also going to be, your pods will be deleted basically, right? So 2 pods are running on the deployment. These 2 pods are running in the each worker node. Now, how to access our application? Load balancer service is available. Take this load balancer DNS, go to the browser. My application context path is java-web-app. So with this, I'm trying to access my application, which is running in the Kubernetes cluster. Right, perfect. I'm able to access my application. So let me give this URL. You can hit this URL. Then you can see my application, which is running in the Kubernetes cluster. I have deployed my application. I have created the pods. Those pods I have exposed by using load balancer service. By using that load balancer URL, I'm able to access my project. Are you guys able to understand? Are you guys able to access? Are we able to deploy? Worker node means a Linux machine, correct? Worker node means one Linux machine. Worker node means one Linux machine. This is my application. My application is available as a Docker image. Using that Docker image, we are able to deploy our application. This is worldwide. Anyone can access, not only for Indian people, this anyone can access. Now I have given the application URL, which I have deployed. Now you can access this application. Are you guys able to access my application now? Any application you can deploy. The only difference, guys, if you want to deploy any other application, the only difference, the image name is going to be different. Okay. So now I am using this Ashok IT / Java web app image that we have deployed. If you want to deploy another application, then you need to change the image. Where is the Tomcat? Where is the code? Everything is part of this Docker image. In the Docker image, our code plus dependencies plus servers, everything will be available in the Docker image. We are taking the Docker image and we are creating the deployment. That's it. Sir, where is Tomcat? Where is Java? Where is code? Everything will be available in the Docker image. So that's why if you know the Docker, then easily you can understand the Kubernetes. Docker is prerequisite to understand the Kubernetes. Nikhil, maybe problem is from your side only. Everyone is able to access, only you are not able to access. Are you using any company laptop? Even from the USA also people can access, no issue. Maybe any firewall settings enabled in your laptop, that's why you are not able to access. Remaining people are able to access. Okay. You want the Docker videos, huh? Yeah, Docker workshop, 3 days Docker workshop I conducted 2 months back, guys. Those Docker videos I will share with you. And this Kubernetes 2 days videos also I will share, notes I will share with you people. Okay, if you want to get this, 1 minute. Yeah. Are you able to access? That is my question. Yeah, I'm giving one WhatsApp group link. You can join in that so that you will get the Docker videos and Kubernetes. So, sir, how to learn Kubernetes in depth? If you want to learn the Kubernetes in depth, you can join for the Kubernetes course. Docker videos, Docker notes, Kubernetes videos, you can get from that WhatsApp group. I have given group link in the chat box. Join in that. Ashok IT Docker Kubernetes workshop WhatsApp group link I have given. You can join in that. When the batch will start? My batch will start after 2 weeks of time, guys. My Docker Kubernetes batch, 1 month we will spend for Docker, Kubernetes and Jenkins. My batch will start after 2 weeks of time. Another batch, another faculty batch available tomorrow morning at 7 a.m. for Docker, Kubernetes and Jenkins. So if you join in that WhatsApp group, you will get all that update. Okay. Yeah. Sir, now I have done the deployment, right? How to delete this deployment? Okay. So once your deployment is created, you can do the deployment deletion also. After practice is completed, delete the resources we have created. Delete resources we have created. So how to delete the resources we have created? By using kubectl delete all -all. So if you execute this command, what all the resources that we have created, all those resources will be deleted. Okay, if you want to delete everything, I have created service, I have created the pods, I have created the service, I have created the pods, and I have created the deployment. I want to delete all these things. In order to delete all these things, then we are going to use kubectl delete command. Kubectl delete all -all, so that all these things, all these resources will be deleted. Okay, so can I show you how to delete and how to create the deployment again? Right, now observe. So if you see kubectl get all -all, then sorry, kubectl get all -all, kubectl get all. Yeah, when I go for kubectl all command, it is showing me what all the resources I have created. I have created 2 pods. I have created 1 service. I have created 1 deployment by using my manifest YAML. So what all the resources that you have created? If you want to get the resources details, then you can use kubectl get all command. Yeah, I will wait for a minute, guys. Yeah, please join in the group. So people are busy in that, not able to focus. Yeah, I have given that WhatsApp group link. Please join so that I will start. Yeah, you can join in that group quickly. I have given the WhatsApp group link, Ashok IT Dockers and Kubernetes. So if anybody want to get the Docker videos, 3 days free workshop I conducted on the Docker. Those videos and these Kubernetes notes videos I will get in that group. And if you want to join for Kubernetes paid course, That also you will get the update in that group, guys. You can join in that WhatsApp group. I will wait for a minute. Quickly complete the joining process so that we'll get started with the remaining topic. All of you able to join? Please confirm quickly. If you are done, then I will start with the session. Should I wait or should I start? Should I wait or should I proceed? Yeah. Fine. Now we are able to create the deployment in the Kubernetes. So we have created several resources in the Kubernetes deployment now. So what all the resources that you have created? If you want to get all those details, then you can use a command called kubectl get all command. Kubectl get all command will be available. That will give you all the resources that we have created by using Kubernetes. All the resources that you have created by using Kubernetes, you can get this information. kubectl get all. We have created 2 pods. We have created 1 service. We have created 1 deployment. Okay. If you want to delete all these things, then you need to use a command called kubectl delete all -all. Then everything will be deleted. Can we see one of the concept called self-healing? As I told you, Kubernetes will provide you self-healing. What is the meaning of Kubernetes self-healing? If any one pod is deleted, Kubernetes will recreate that. Can we check it? Can we prove that practically? Is Kubernetes providing self-healing or not? There are 2 pods running. I will delete 1 pod and I will see the behavior of the Kubernetes. I will delete 1 pod and I will see the behavior of the Kubernetes. Okay. Now observe. You can see the count kubectl get pods. There are 2 pods running. Now, these 2 pods, you can see age of the pods. From the last 15 minutes, these 2 pods are running. kubectl get pods command. From the last 15 minutes, these 2 pods are running. Now, what I want to do is delete it. kubectl delete 1 pod. I'm giving pod IP. kubectl delete pod with the pod name. kubectl delete pod with the pod name. Now pod is deleted. So now you see earlier there are 2 pods available. Those 2 pods are running from the 15 minutes. Now I have deleted 1 pod by using kubectl delete pod name. Now check the pods count. Get pods. Again 2 pods are available. So 1 pod is running from 16 minutes. Another pod is running from 18 seconds. That means Kubernetes recreated the pod. Is a self-healing available? Is the self-healing available in the Kubernetes or not? If any one pod is deleted, another pod it created. High availability. So I have given the replica cells too. So always 2 pods will be maintained. If 1 pod is deleted, then it is creating another pod that is called self-healing. Kubernetes is having self-healing. Are you able to prove that Kubernetes is having self-healing? If both pods deleted, and then again 2 pods will be created. If both pods are deleted, another 2 pods will be created. Okay. It no need to identify which pod is deleted. If 1 pod is deleted, another pod will be created. That's it. If 1 pod is deleted, then another pod will be created. That is called self-healing. Self-healing, nothing but if any one pod is deleted, then it will create the another pod for that. Now let me do that once again. Let me check the kubectl get pods command. Yeah, one pod is running from 17 minutes, another pod is running from 97 seconds. Let me delete the old pod. How to delete it? Kubectl delete pod name. Select it. If you select it, it will be copied. Then paste it. Delete that pod also. Old pod, which is running from 17 minutes, I have deleted. Then check the pods immediately. Another pod came. 5 seconds ago, one more pod got created. So if you delete one pod, Kubernetes is creating another pod. That is called self-healing. This is one of the biggest advantages in the Kubernetes. High availability will be there for our application. Now, I want to check the logs of the pod. kubectl logs give the pod name. Then you can paste it. kubectl logs of the pod. It will display how your application is executing. Your pod logs will be printed. If any pod is damaged, if any pod is crashed, if any problem occurred in the pod, how can we check the logs of the pod? By using kubectl logs command, you can check the logs of the pod. In the interview, they will ask this question also. My pod is having some problem. How do you troubleshoot that problem? By checking the logs of the pod. How to check the logs of the pod? To check the logs of the pod, we will use kubectl logs command with the pod name. So this is the pod log. It is going to display how our application is started. This is my Spring Boot application. This Spring Boot application is running in the Tomcat server with the port number 8080. So internally, it is using Tomcat server to run our application. That Tomcat server running on the port number 8080, that 8080 port number is called as our container port number. Whatever the 8080 port is available, that 8080 port is called as our container port number. Are you guys clear with my point? Okay. Now, next, I want to do the deletion. I want to delete everything which I have created. To delete everything which we have created, kubectl delete all all the resources will be deleted. My pods are deleted, my services are deleted, my deployment also getting deleted. If you want to clean up the cluster, then you can use this command kubectl delete all all. What are the resources that we have created in the cluster? If you want to delete all these resources, then you can use kubectl delete all all. So whatever the deployment is created, the deployment got deleted. Whatever the deployment is created, the deployment got deleted. Are you clear with my point? Are you clear with my point? Okay. Now, whatever the deployment that we are doing manually, we are executing kubectl command manually. But in the real time, the deployment will be created by using a CI/CD pipeline like this. Okay. We are going to create one CI/CD pipeline by using Jenkins. So when we run this Jenkins pipeline, then what will happen? Jenkins will take the code from the Git repository. Jenkins will build that code by using Maven. Jenkins will create a Docker image for the application. Then finally, that Docker image will be deployed in the Kubernetes cluster. This is our Jenkins CI/CD pipeline. Developers will be available for the project. Developers will write the code and they will push that code to the Git repository. Then the Jenkins pipeline will trigger. That Jenkins pipeline will take the code from the Git repository. Then Jenkins will build the code by communicating with the Maven. Code compilation, code packaging will happen by using Maven. Once the code is packaged as a jar file or war file, then Jenkins will communicate with the Docker. It will create the Docker image for the application. That Docker image we are going to configure in our Kubernetes manifest file. This is the Docker image. Once the Docker image is created, then Kubernetes deployment will happen by using that Docker image. This is called CI/CD pipeline. So in the real time, the project deployment will happen with this CI/CD pipeline. Docker image creation, Kubernetes deployment will happen. Okay, guys. Here, so if you know this is Jenkins, Docker, and Kubernetes, then you can build this CI/CD pipelines. So in the real time, DevOps engineers are responsible to create this CI/CD pipeline. DevOps engineers are responsible to build these Docker images. DevOps engineers are responsible to create the Kubernetes manifest file and create the deployment of the application. As a developer, you should also have some idea what is the CI/CD pipeline, how Kubernetes deployment will happen, how to check the logs in the Kubernetes, how to check the pods in the Kubernetes, what is the Kubernetes manifest YAML, what is pod, what is service, how many types of services available. This idea should be there for the developers also. Nowadays, for the developers also, they are asking the questions related to DevOps tools. How to create CI/CD pipeline by using Jenkins, how to build a Docker image by using this Docker, how to deploy the Docker image by using Kubernetes, what is Kubernetes cluster, everything. So in my Jenkins Docker Kubernetes class, 1 month we are going to spend to develop this pipeline. So if you spend 1 month of time, then you will become expert in this CI/CD pipeline. What is Docker? How to work with Docker? What is Kubernetes? How to work with Kubernetes? How to write the manifest YAML? What is Jenkins? How to work with Jenkins? How to integrate Jenkins, Docker, and Kubernetes? How to do the CI/CD pipeline by integrating all these 3 tools. For these 3 tools, we are going to spend 1 month of time. In our DevOps course, we will spend 1 month for only 3 tools: Jenkins, Docker, Kubernetes. But this 2 days workshop to get the idea what is Kubernetes, why Kubernetes, how to use Kubernetes. If you want to become expert in the Kubernetes, then you need to spend minimum 10 to 15 days of time to learn only Kubernetes. For Docker 1 week, for Jenkins 1 week, for Kubernetes 2 weeks. So total, it is a 4 weeks program to become a good CI/CD, to build a good CI/CD pipeline by integrating Jenkins, Docker, and Kubernetes. I have one video also. I have explained one project by integrating all these 3 tools, guys: Jenkins, Docker, and Kubernetes. I will upload that video also. I have prepared one video. In my previous DevOps batch, I have taken one class. By integrating all the 3-4 tools, I have created one project. 1 hour video is there. I will upload that video in our YouTube channel. I will share that link also in our WhatsApp group. The final integration you can see. The integration you can see. Okay. My Kubernetes, Jenkins, Docker new batch will start in 2 weeks of time, guys. So you guys can join for that, and you will get the update in that WhatsApp group. So Ramsar batch is available tomorrow morning at 7 a.m. for the same concept: Jenkins, Docker, and Kubernetes. My batch will start in 2 weeks of time. Yeah. If you join complete DevOps, the fees is 18,000. If you join only Docker, Kubernetes, and Jenkins, fees is 8,000. Okay, my new DevOps batch is starting from next Wednesday, guys. Evening at 8 p.m. my new DevOps batch is starting. You can join for the new DevOps batch. In that, you will learn all the DevOps tools and AWS cloud also. Linux already we are giving for free of cost at 6:30 p.m. My new DevOps batch is starting from next Wednesday at 8 p.m. 18,000 is the fees. In that, you will get Linux plus DevOps plus AWS, including the projects. In the DevOps, Docker, Kubernetes, Jenkins also will be covered. So instead of paying 8,000 for these 3 tools, it's better to go with the DevOps batch so that you will get all the remaining tools also. Okay, how to check the logs of the pods that we are able to see? Check the pod logs. How to check the pod logs? To check the pod logs, we are using a command called kubectl logs pod name. kubectl logs pod name. Then how to delete the pod? Delete a pod. If you delete the pod, a new pod is getting created. Delete pod. To delete the pod, we are using kubectl delete pod and pod name. If you delete the pod, then again new pod is getting created. Okay, good. So this is about the commands, guys. So here there are some other important videos also related to this Kubernetes. How to set up ELK stack in the Kubernetes, EFK stack setup in Kubernetes. So I have taken one video how to do the log monitoring by using EFK stack. That video is also available. And how to do auto scaling in the Kubernetes by using horizontal pod autoscaler. Okay, logs monitoring, Ashok IT. So in this, there is a video I have explained how to do the EFK stack setup in the Kubernetes to do the log monitoring. I will give this video link also in the notes. EFK stack setup in the Kubernetes. HPA, horizontal pod autoscaler in Kubernetes. how to set up horizontal pod autoscaler in the Kubernetes. That video is also available. HPA setup. We discussed that in the Kubernetes autoscaling is available. Horizontal pod autoscaler setup is there in the Kubernetes. That video I have given in the notes, right? Yeah. And the next one, Docker 3 days workshop I have conducted, guys. So those videos links also I will give here, and these notes I will share in the group. You can access all these things. I think very recently we have conducted the workshop on the Docker. Let me take those 3 videos. Docker, I think we have posted day 1, day 2, day 3. Yeah. Day 1 video for the Docker. Day 1 video is available here. I will share these video links. Yeah. So I think 2 months ago only I conducted a free workshop on the Docker. 3 classes I have taken for this one. I will give this link. So how to access this Docker workshop. Okay. I will update all these video links in the notes, and I will share these notes in our WhatsApp group. Thank you, guys. Thanks for joining this workshop.